Hello, I'm Benjamin Lewis,
And I'm Jarren Worthen.
and we are in the Utah State University ECE 3710 microcontrollers class.
And today we are here to demonstrate and explain our micro music synthesizer. So let's check it out.
First, I'd like to explain the inputs to our micro music synthesizer system. Our original idea was to have a keyboard so you could play music on it. And we were going to use a USB keyboard connected through the USB port on our STM development board. However, because of the difficulty in using USB and the unavailability of the drivers, as well as the time frame of our project, we opted instead for a custom keyboard built out of several buttons. So as you can see here are buttons to control the different notes of a 1-octave scale, as well as buttons and a dial for configuring the synthesizer. These buttons are connected to different GPIO pins on the development board and ground, so that when the button is pressed, the GPIO pin is then pulled to ground. When the button is not pressed, there is a pull-up resistor pulling the GPIO pin to high. We also have a 1 kilo ohm potentiometer here connected to an ADC on the development board. The potentiometer here, when twisted all the way to the left, the ADC reads 0 volts, and when twisted all the way to the right, the ADC reads 3.3 volts.
I'd now like to talk about the outputs of the micro music synthesizer. First off, we're using the LCD screen to display what mode the micro synthesizer is in. As you can see right now, it's in configuration mode. If I press the button to go into play mode, we're in play mode. We can also go into the different modes to say different things of what waveforms we're changing. We'll go into that later. Now I'd like to talk about how we are outputting the audio. As you can see, the microcontroller has an audio jack built on the board. This microcontroller is controlled by a separate controller on the board. The microcontroller talks to that through I2C via the serial audio interface. The serial audio interface uses the direct memory access. It was our original plan to use that serial audio interface in order to interface with this audio jack. However, because the serial audio interface is primarily designed to use the direct memory access, and our synthesizer doesn't play from a file, it generates its own waveform, we felt it would be better to not deal with the serial audio interface. And so as you can see, we are instead using a DAC to interface with a simple female audio jack that is plugged into a GPIO port in the board. That can be plugged into any speaker or headphone system, and it will play music, as you can hear. Great. Now I'd like to talk about the processing that the micro music synthesizer uses. First, let's talk about the states in the state machine that the microcontroller uses. As I showed earlier, right now it's in play mode. In this state, a user can press any of the notes here, and it will generate that waveform. We can move then into the configuration state by pressing the configuration button. As you can see, it now says configuration here. From this menu, we can select 4 of the different types of sine waves that we can configure: sine, ramp, triangle, and square. So you can see we can go into the sine wave, and the sine wave is now at 100%. This can be changed by this potentiometer. So I can leave that at 100%, go back into configuration menu. Let's change the ramp to 0%. We can go back and do the same thing for triangle and square, so that now the master wave is just a pure sine wave. We can go back into play mode, and now we're playing a pure sine wave.
Next, I'd like to talk about the audio processing that our microcontroller does. The audio processing is done by timers inside of the microcontroller that use these 2 major formulas. So the first formula calculates the value of a specific note when a note is played. This value ranges between 0 and 1. And it is calculated by using these constants, sine k, that are selected by the configuration mode. And so we have sine k multiplied by the current position in the sine table, which is a table generating a sine wave, added with the ramp k from the configuration mode, multiplied by the ramp table, and so on with the triangle wave and the square wave. So this is an additive mixing algorithm to add all of the different base waves together into one master wave. This master wave is then scaled by the sum of all of the scalar values in order to bring it back to a 0 to 1 range. And so that is the formula to calculate the value of a note at any specific time. And here at Formula 2, we have the formula to determine the output to the DAC. And this is taken by the sum of all of the note values, adding all the note values together, which is what naturally happens when multiple notes are played together on an instrument. And then we scale that by the number of notes being played back down so it's between 0 and 1. We then multiply that by a volume constant, which is determined by the potentiometer while in play mode. And so this is all the basic of the audio processing that goes into the micro music synthesizer. And now I'll explain how the microcontroller generates the note values. To generate the note values, the microcontroller has 3 timers. Timers 1, 2, and 3. And in the main function of the microcontroller, it scans through all of the notes, starting with note C and working its way up. And when it scans a note, it follows this algorithm. So if the note, in this case G, is pressed, and if no buttons have been pressed, we set timer 1 to generate the note G. If one button has already been pressed, we set timer 2 to generate the note G. If 2 buttons have already been pressed, we set timer 3 to generate the note G. And after we've set the timers, we increment the number of buttons pressed so that we can keep track as we scan upwards. And if G is not being pressed, we release all timers so that other notes can use them to generate that note.
So now we'd like to demonstrate how the music synthesizer works. Right now we have it configured such that the sine wave is the only waveform being used. As I already showed, I can play different waves. So if I'm playing C, there we go. If I play a much higher note, the frequency is much higher. But let's say I wanted to not play a sine wave, but a ramp wave. If we come back, I'm going to press configure. We're now in configuration mode. I'll then press ramp and set that to 100%. We'll go back and set all the other waveforms to 0. And now we go back to play mode. I move the volume back up and put it down a little bit so you can see that. We can also play chords. But what we really want to do is show you the real cool part about the music synthesizer.
Now, the fun part of a music synthesizer is building your own custom waveforms and playing music with them. So now we're going to demonstrate that. So as we showed before, we can customize our waveform by going into the configuration mode. So here, we're going to use just a little bit of sine wave, maybe around 30%, large ramp wave in the 80s, a decent amount of triangle, and a decent amount of square. And so now we've built our own custom wave. You can go into the play mode, and using the oscilloscope, we can see and at the same time hear what our wave looks and sounds like. And so there's our custom waveform. We can play chords with it. And get all sorts of different shapes. And then, with our new waveform, we can play our own music. And that concludes our explanation and demonstration of the micro music synthesizer. We hope you enjoyed it.
If you have any questions, please leave them in the comments below. We'd love to hear from you. Thank you.